Hello, sixth graders. This is Mrs. Seeley with another math lesson. And today we are doing Chapter 6, Lesson 5, Expressions, Equivalent or Not. So let's think of this term equivalent. And when we're talking about equivalent fractions, equivalent expressions, it means that the two sides of the equal symbol that we're looking at have the exact same value. So when we look over here in this blue square, we can see that we have the absolute value of -7. It's equivalent or equal to 17. It has the same value. The same is true for 3/6. Its equivalent fraction is 1/2. Both have the same value, and I want you to think about this equivalency as a scale. When a scale has equal weight on either side, that it is a balanced scale, and each side carries the same weight. And in terms of equation, each side of an equal symbol carries the same value. Now, if you look over here in the red square, you can see we have some things that are not equivalent. So the absolute value of 17 is not equivalent to 6. 3/6 is not equivalent to 1/3. And so when you think of a scale, you can look at it as a scale that is not balanced. That means one side either has a larger or smaller value than the other. And so we can think of that as not equivalent or not equal. And so when you're thinking about equivalency, keep in mind that idea of a balanced scale versus a scale that is not balanced. A few other things that you need to keep in mind are some properties of numbers, and you have learned these before. It's maybe been a while, so we're going to do a quick review. This first one is called the commutative property, and I have it here highlighted in yellow. This is only true for addition or multiplication. So this is a very important thing to remember. And what that means is when we are adding or multiplying, the order of the numbers, they don't matter. Okay, it doesn't matter. So if you look at the examples, 7 plus 9 is the same as 9 plus 7. We can use some variables to show that same type of equation. Also, 4 times 6 is the same as 6 times 4. So how do we really know, however, that it's not true for subtraction? Well, let's take a look at it. Is 9 minus 7 the same as 7 minus 9? No, it is not. So the commutative property does not work for subtraction. Well, how about that division? Let's take a look at that. Is 6 divided by this 3 the same as 3 divided by 6? Well, no, they're not. And so we can say that the commutative property also is not true for division. And this will be important for you as we go through this lesson. The next property is something called the associative property. It is also only true for addition and multiplication. And what that means is when you're adding or multiplying, the order of the numbers, how the numbers are grouped, however, and when I mean grouped, they are in parentheses, that doesn't matter either. Okay, so let's take a look at this one. 7 plus in parentheses 9 plus 4 is exactly the same as 7 plus 9 in parentheses plus 4. And again, we can do this with variables. And the same is true for multiplication. 8 times in parentheses 5 times 7 is the same as 8 times 5 in parentheses times 7. So that order does not change the sum, the answer to the addition problem, or the product, the answer to the multiplication problem. But let's prove that you can't use the associative property for subtraction. Take a look at this. 7 minus, in parentheses 3 minus 1, or in parentheses 7 minus 3 minus 1. You get completely different answers because we are using order of operations and we do parentheses first. We can tell right away that these two expressions are not equivalent. We did not land in the same place, so the associative property is not true for subtraction. Let's take a look at division. You can see, because we're using the order of operations, we're doing our parentheses first, we can see that our quotients, our answers to these division expressions are completely different. So these expressions are not equivalent. Therefore, the associative property does not hold true for division. Okay, so let's take a look at this. You have two options when you're deciding whether expressions are equivalent or not. One is you can use what you know about those properties, the commutative property and the associative property. So for example, if I look at these two expressions, I can see right away that this is the associative property. I know that the associative property is true for addition, so I know these two expressions are equal. The other strategy you can use, and the one that I prefer to use, is just do the math, figure it out. So when we figure out these two expressions, we end up with 28 for both of these. And then it is very clear that these two expressions are equivalent. Let's look at this one. We have the associative property here, but this is division and subtraction. Got it all messed up in here. So this can't be equivalent. I mean, based on what we know about these properties, right? This can't be equivalent. But I always love to prove it by doing the math. And when I do the math, this is what I get. I get two completely different answers. So these expressions are clearly not equivalent. And here we have some multiplication, and it looks like the order has been switched. That is the commutative property. From what I know about the commutative property, it is true for multiplication. So I can say they're equivalent, right? This is what I know. Again, I'm the one who likes to see those numbers. I like to prove it. So I'm going to do the math. And when you do the math, both expressions equal the same amount. And so we can confidently say that these are equivalent expressions. So now it's your turn. We have 4 expressions here that you are going to compare with another expression to determine if they're equivalent or not. Your job is to pause the video here, decide if the expressions are equivalent or not, but you also have to have an explanation as to why you got the answer that you got. So pause the video here and go through all 4 problems and then come back and check your work. All right, nice job. Let's go ahead and see what you came up with. Let's look at this first one. So let's see if we can get it to go. There we go. This first one, I just used what I knew about the property, the associative property, right? And I know it's not true for subtraction. So I said this is absolutely not equivalent. For the second one, I decided I was going to do the math. That's my preferred method anyway. And when I did the math, I got the same answer for both expressions. So they are definitely equivalent. Now looking at this third one here, take a look at it, right? You could use what you know about the properties, associative property, or you can just simply do the math. Again, that is my preferred method. So I just did the math, and you can see that they are both equivalent. Now this last one's kind of tricky because look, it's the associative property. It has addition. It has multiplication. I know the associative property is true for those 2 operations, but I don't know if those operations can be mixed. So here's where doing the math comes in handy. I am not sure, right? Are you sure? So let's just simply do the math. And when you do the math, you get 2 completely different answers. And so we know now that those operations cannot be mixed. But you can see how doing the math often will be the surest way to know whether expressions are equivalent or not. So good job. This is exactly what you're going to be doing on your independent practice. You are going to be determining whether these 2 expressions that are given in these 4 problems are equivalent or not. Your job is to drag the equal symbol or the not equal symbol into the box. Also, then you must explain how you got your answer. Now, you can type your explanation in the box here, or you can insert a picture of your work where you showed the math. Either way, you have to have an explanation for your answer, okay? And there are 4 problems that you are required to do that require you to determine whether expressions are equivalent, and you need to have an explanation. Then you will have 4 review problems, and you must post a picture of your work. If you can figure out how to type your work and have it all lined up and nice and neat and have it make sense, by all means, type it. Easiest way, I think, is to go ahead and insert a clear picture of your work. Okay, so that is your math lesson and independent practice for today. Let me know if you have any questions. We will be around for office hours. All right, see you later.